Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about the question bank discussion on the module Beyond Classical Search for this particular course, Applied Artificial Intelligence. Already in my previous video, I have discussed few definitions and terminology for all the 5 modules. Now from here onwards, next 5 lectures, I will discuss all the question banks. Almost I will try to cover, but few I cannot cover because of the time constraint. So this is the course outcome which map to the first module, and after the completion of the complete course Applied Artificial Intelligence, student can discuss the appropriate search strategies and knowledge representation techniques to implement inference mechanisms for AI-based problem solving. Okay, let me discuss related to Beyond Classical Search. This is the first question I want to discuss over here. The question given is, classify different types of local search algorithms used in continuous spaces and describe the scenarios in which each algorithm is most suitable. First of all, we should know what is the meaning of local search algorithm. Local search algorithm is not like our informed search or uninformed search. The search which can be made which is used to perform to find out the optimal solution over using different types of methods. Okay, so that is called as the local search. So different types of local search methods are used in continuous spaces, and the different examples also I will discuss here. So local search algorithm in continuous spaces are used to find the optimal solutions by exploring the neighborhood of the current solution without building an explicit search tree. As we have already known in our informed search and uninformed search, like best first search or breadth first search or depth first search or A star or AO star, where we used to draw the tree, means tree would be given, and based upon the distance from the initial node to the goal node, we can find out the solution. But here, if the space is like the continuous space, like hilly space, or if the space is like more hills are there like this, then in that case we cannot apply this search method. So it is very difficult to apply. So that is why we'll go for the local search algorithm. So different types of local search algorithms are there to find out the optimal solution. The first algorithm is the gradient based local search. As per the question, it is given that we have to describe the scenarios in which each algorithm is most suitable. Different types algorithm as well as the scenarios where it can be used. So first the algorithm for local search is the gradient based local search. What is the meaning of here the gradient? Gradient means the slope of the point at a particular moment of time. That is called as the gradient. So if the local search is based upon the slope, then we can say it is a gradient based local search. So these methods use the derivative information to guide the search. That means if slope is given, like the equation like y is equal to mx plus c, then we can find out the derivation of dy by dx, right? So we can find out. So these methods uses the derivative or the gradient information to guide the search. Then what is the meaning of gradient descent? So gradient descent means which moves the direction of steepest descent using the gradient of the objective function. Here, what is the meaning of the objective function here? Actually, objective function, it is a function. Suppose the space is like this, and this is the continuous space, and the objective function at this moment. So objective function is like this type of y is equal to mx plus c. Just I have given one example. Similar kind of equation would be given. So objective function for a particular point in the local search, what it says that whether the solution at this particular moment is a good solution or the bad solution. If And how we can recognize how the machine can recognize the solution at this point is a good solution or bad solution. Always it tries to find out, using this gradient based method, it tries to find out the gradient of the next neighboring point. Maybe the next neighboring point here, maybe the next neighboring point here. So either in the forward direction or in the backward direction, to find out which point is the best solution among all possible solutions. That is called as the optimal solution. So in local search algorithm, as it is dedicated to find the optimal solution out of all possible solutions using gradient based technique, that too using the objective function. So gradient says that the agent moves either in the steepest descent or steepest ascent using the gradient of the objective function, and especially it is suitable, this type of gradient based algorithm is suitable for smooth, differentiable and convex problem. For example, optimizing the loss function in the machine learning. Like smooth surface means this type of surface means where the space is completely smooth. If I draw this diagram, if this type of diagram, this is not smooth, many curves are there, but here only one peak point is there. So this type of space is called as the smooth space and differentiable. If the objective function is differentiable, like y is equal to mx plus c, we can differentiate, we can find the differentiation of this equation using dy by dx. Already we know. And the convex problem means if it is having only one optimal solution, then in that case we can say this type of continuous spaces where we can find the optimal solution can be done using the gradient based technique. So this is one method. The next method is non-gradient local search. Non-gradient means no slope, means we cannot find out the derivative free, or derivative free we can say, means the objective for the objective function we can the objective function is not differentiable. So especially it is useful when gradients are unavailable, noisy or expensive to compute. That means gradients means slope will not be available. If I draw this diagram, like peak point, then it comes down, so slopes are not there. And even if I find the slope also, it would be not differentiable. It would be very expensive to find out the differentiation of the objective function. So in that case, what we can, in non-gradient method, we can go for different types of algorithms to find out the optimal solution. So the first algorithm is the random search, second one is the hill climbing, and third one is the simulated annealing. So in random search, what it says, as the name it implies, a random search randomly searches a particular solution at any point. So it explores the space randomly to find out the better solution. It's not like it starts with the initial position, starts with any solution at any point. And especially it is suitable for highly nonlinear or discontinuous function when no gradient is available. So it's a very simple statement. That means if the slope is not available and the space is discontinuous, means it is not differentiable and non-linear. It is a non-linear type of space where many hills or many humps are there or many levels are there. In that case, we cannot go for gradient based method. We can go for random search. Now, if you see the hilly area, like if the space is like this, it is continuous. It is continuous because the space, we can find out the slope here, then we can find out the slope here, then we can find at this point, then again this is steepest ascent, this is steepest descent. Like this, we can find out the point where the solution we can get the maximum benefit. That point would be considered as the optimal solution. This is related to the gradient method, but this is related to the non-gradient method where slope we cannot find and it is discontinuous in nature. So this is related to the non-gradient method. Another algorithm which is used for non-gradient method is hill climbing. So hill climbing is similar to your random solution or random method, random local search, which iteratively moves to a better neighbor, and it is suitable for simple unimodal optimization problem, and it may get stuck in the local optima. So hill climbing problem, what it says that, like first of all, it works with a smooth surface, smooth surface, and iteratively try to move to a better neighbor. That means, like the random method, random algorithm, it starts with any solution. So for example, this is the solution at this point we find. Then the AI agent tries to find out the next neighboring solution, maybe here or maybe here. So on, and this process continues until the no optimal point, no further it moves, the solution will be calculated for the neighboring solution, and whenever the neighboring solution is better than the previous solution, then the neighboring solution would be considered as the final solution, and this process continues until no further solution is found. So basically it is suitable for simple unimodal problem. Simple means when the space is having only one pick point or one curve, and unimodal optimization problem, the same meaning, simple, the space may be very linear first of all, which is differentiable, and unimodal optimization problem. Unimodal means maximum one curve would be there. Okay, so but the problem with the hill climbing is it may stuck at the local minima. Suppose this position, suppose let me erase so that I can give you the clarity of what is the problem with the hill climbing. Suppose the hill is like this, okay, like this. Then when suppose the solution starts here, the agent will start here and moves forward and finds the peak point over here. So this is the best solution among all the solutions. As per the hill climbing problem, always the neighboring solution will be considered. If it is better than the previous solution, then the neighboring considered as the great solution or the good solution. So and this process continues until the optimal solution is found. So after reaching this point, means this point is the peak position of at this moment of time. So once it reaches, that means it considers that this point is the optimal solution. It never falls again, it does not come down again, because though it is a good solution for this particular space, but better than this solution, one more solution is also there, but it is difficult for the hill climbing problem or hill climbing algorithm. It is difficult to find out the next optimal solution. So that is the biggest problem. So that it says it may get stuck at the local optima. So this is the stucking point, which is called as the local optima. But one more optimal solution is there. This is called as the global optima or global solution. So that is the drawback of the hill climbing. And one more algorithm is there, which is related to non-gradient method, like simulated annealing. It is a probabilistic method. Probabilistically accepts the worst solution to escape local optima. So probabilistically it will find out, suppose the area is like this, okay, like this. Then it may start probabilistically, so probabilistically accept the worst case solutions to escape the local optima. That means what? It may starts with this, it may not find the perfect solution here and here. Then again it comes back to the original location. If it does not find the good solution, it comes back to the original location. Again it starts from the original location and tries what it does, the agent will try another path to reach the optimal solution. So it may try in this way also, it may try and moves to the optimal solution. So that is why it can go to the worst solution to escape the local optima. So suitable for multimodal problems. Multimodal problems means where the space is having more than one curves. If there is only one curve, then hill climbing is possible. If there is more than one curves, then that is called as the multimodal problem or global optimization in continuous domain. Then the third type of algorithm method which is used in the local search is evolutionary method. So evolutionary method, which is a population based and adapt over the iteration. And in evolutionary method, one of the important algorithm is genetic algorithms. So why the method is called as the evolutionary method? Here no slope, no gradient is used. Evolutionary means more number of solution automatically it will come or will be generated, and out of all solutions, one solution will be considered as the optimal solution. So one of the algorithm which is there in the evolutionary method is genetic algorithm. So genetic algorithm uses the crossover and mutation of a population of solutions. So crossover and mutation means crossover where from many solutions one solution will be considered as the final solution, and mutation means from the final solution can be modified to generate the optimal solution. That is called as the mutation. So especially it is suitable for complex problem as well as the multimodal optimization where the global search is needed. Multimodal optimization means if the local search is having more than one curve, that is called as multimodal optimization problem. So this is all about different types of algorithm, and I discussed The first algorithm is your gradient based algorithm, second algorithm is your non-gradient, and third one is the evolutionary method and where it is used. But if the question comes for 6 to 7 marks, then you have to you have to elaborate the things, but because of the space constraint and time constraint, I have explained only the important points that you have to explain and you have to elaborate on the paper. The next question is compare and contrast the use of gradient-based search methods with non-gradient-based method in continuous spaces. Discuss the strength and weaknesses of each approach in terms of convergence speed and handling the local minima. So what we will discuss over here, all the things for this question, if it comes in your exam, you have to elaborate, you have to compare in the form of tabular format, and you have to find out, you have to write the strength or weakness, strength and as well as weakness for each of the approach in terms of convergence speed and handling the local minima. Means how the local minima can be handled for each algorithm and how the time can be managed, which is called as the time terms of convergence. Now, let us discuss the solution for this problem. First one is the gradient based. The two algorithms here as per the question is given. One is the gradient based method. Second one is the non-gradient based method. So, based upon the criteria, we'll find out what would be the solution. So, based upon the convergence speed, if we talk about the convergence speed, then for gradient based method, it is very fast. Why it is very fast? But in case of the non-gradient based method, it is slower due to the random and heuristic steps. So, as I have already discussed in my previous question, gradient based method, when it is applicable, if the space is very linear, means the objective function is differentiable. In case of the non-gradient method, the objective function is non-differentiable like this. Here the slope we cannot find out, and if we find, it takes more time and it would be cost. More cost would be required. So that is why based upon the convergence speed, the gradient based method, it is very fast, whereas the non-gradient method, it is slow. And the next criteria is local minima handling. Local minima means first minima optimal point. So for finding the local minima point, local minima location, it is very poor in case of the gradient based method. It gets trapped easily. But whereas in case of the non-gradient method, it is better. Because why? It can escape using the probabilistic moves. And coming to the function requirement, it requires the gradient based method requires smooth and differentiable function, because the objective function, it can work in the smooth space and it is differentiable, whereas it works with, but the non-gradient method, it works with the noisy, discontinuous or black box function where the objective function is non-differentiable. And based upon the computational cost criteria, generally it is the gradient based method generally lower per iteration, whereas the non-gradient method higher due to the population based or random sampling. So these are the differences based upon this, based on all these criteria, finding the local minima and the convergence speed. And then the next question, but as per this question number 2, as it is given, if the question, if you get like for 6 to 7 marks, then you have to elaborate on your paper either in the tabular format or you have to explain the paragraph format also, but with explanation and example. Here I have given the points, all these points you have to elaborate. Then the third question is explain the role of step size in local search algorithms for continuous spaces. Discuss how varying the step size can impact the search process and the likelihood of finding an optimal solution. The question is about the step size. Now let me discuss what is the meaning of the step size here. The step size is also called as the learning rate or move size. That means, suppose for example, the agent is moving in a continuous space, okay, with the objective function here y is equal to mx plus c. Then it tries to find out the next optimal solution or the next best solution. From here to here, how much the cost is there or how much distance is there, and for one iteration, how much space it takes, or whether it is moving to a large step or whether it is moving to a small step, means covering a small step. That is called as the learning rate of the transformation or learning rate of the movement. So step size is called as the learning rate, or it is called as the move size, which determines how far a local search algorithm moves in the search space during each iteration. One iteration, how much space it covers. For example, another iteration, it covers this much. Another iteration, it covers this much. So this distance, in each iteration, it is covering a minimum, or it covering low step size or higher step size. That is called as the learning rate. How fast the algorithm learns to find out the optimal solution. In technical term, it is called as learning rate. So it plays a crucial role in balancing the exploration and convergence. Exploration means like it can explore based upon the learning rate or the move size. We can identify how fast the agent can explore the complete search space within a stipulated time. That is called as exploration and convergence. Now, what is the impact of the step size on the search process? In the question, it is given impact as well as one more. Yes. What is the impact of the step size on the search process? So now we'll discuss what are the impacts. So if the step size is too large, then what happens? If the step size is too large, then it promotes the wider exploration. That means it can move like from here to here. It can move promotes the wider exploration. That means it can quickly cover the whole space with swallow the local minima. That means it can quickly escape swallow local minima. That means if the learning rate is here, from here to again here, again from here to here, that means sometimes if while moving or while exploring the path, if any local minima is found, that will be ignored. That is the advantage here. If it takes a large step size. But the problem is it may overshoot the optimum. Might miss the best point. So while exploring, it may overshoot the optimum. Maybe this point would be the optimal point as per our perception. So it may not be possible. So it may overshoot the optimum, might miss the best point, and it can cause the instability or oscillation around the solution. So these are the advantages or disadvantages if it takes a large step size. Means the learning rate is high. Compared to the high learning rate, if the learning rate is small, means small step is there, then it allows the fine-tuned convergence to local minima and increases the precision near optimal points. That means it will cover slowly, it will smoothly, it will cover the whole space, and it can find out the optimal solution in a best way also. But the problem is slower convergence. Slower convergence means it takes lots of time to complete or to explore the whole local space, and it may get stuck in the local minima or the flat region, which is called as the plateau. Plateau means, like, for example, the space is like this. So this is called as the flat region, where after reaching here, the agent may stop, or it may get stuck at the local minima point or the flat regions, because for all the flat region, the objective function values are same. So that region is called as plateau. Okay. Now you can see the example for this question. In gradient descent method, a large learning rate can cause the divergence, while a small step size can lead to slow learning. But in case of the random search, the step size control how far the candidate solutions are sampled from the current one. So the step size is a critical parameter or important parameter in the local search for continuous spaces. So choosing or adapting it effectively increases the chances of both efficient convergence and finding a global or near global optimum. Now let me discuss about another question. Compare ontological engineering with traditional knowledge. Compare ontological engineering with traditional knowledge representation techniques. Explain with the help of example. So here two terms are there. One is the ontological engineering and the traditional knowledge representation technique. So ontological engineering is one concept already I have discussed when I prepared my previous videos. It is one of the knowledge representation technique in artificial intelligence. What are the traditional knowledge representation technique and the ontological engineering, that we will differentiate with the help of example. Now, for the question I have prepared in the form of tabular format, you can write like a paragraph also, but separately you have to write for ontological engineer and separately you have to mention for traditional knowledge representation. So if I talk about the definition for ontological engineering, it is a structured approach to formally define the concepts, relationships, and the rules in a domain using ontologies. So ontologies means how the knowledge, because we human beings have the knowledge by birth, but to make the machine intelligent, we have to provide the knowledge. We have to share the knowledge from the domain experts. So if the knowledge is represented in the form of class, okay, in the form of subclass, and the relationship between class and subclass, that is called as the relation, okay, then it is and the rules, and then to define the class, to define the subclass, we used to write follow some rules, then it is called as the ontological representation of the knowledge. And especially the ontological engineering is used to represent the knowledge over the web, so that irrespective of any application, AI application or software, they can share their knowledge. That is the advantage of ontological engineering. Now you can search this video, especially ontological engineering already I have created in my previous lecture. You can follow it to understand completely. Now, what is the definition of the traditional knowledge representation? So it is a technique to encode the domain knowledge using formal structures like semantic networks, frames, rules, and logic. Semantic networks where it is a meaningful network. That is why the name is called a semantic network. It is created with the help of nodes like these nodes and some edges. Okay. And nodes may be the class or subclass or the attribute and how they are related to each other. So like this we can create. This type of network will be created, and from the network which is meaningful, that means it gives some conclusion, then this is the way we can represent the knowledge. Another one is the frames and rules and logic. Frames means where the knowledge can be represented in a tabular format or in a structured format. Rules, different types of rules are used, or the proposition like commutative rule or axiom, different types of axioms and protocols. Logic means either the proposition logic or the first order logic. So those type of representation of knowledge in artificial intelligence is considered as the traditional knowledge representation technique. Whereas if we represent the knowledge using the class, subclass, and rules over the web, that is called as ontological engineering representation. Now, the main focus of this ontological engineering representation is it emphasizes the shared understanding, standard vocabulary, and interoperability across the system. So what is the meaning of this one? Emphasizes the shared understanding as we can represent over the web, irrespective of this interoperability. The meaning of interoperability means irrespective of any domain or any AI application, they can share the knowledge using, because standard vocabulary is used. How we used to write the code using HTML, DHTML, JavaScript or VBScript, the similar type of code we will use to represent the knowledge over the web. So that is called as ontological engineering. As it is can be represented over the web, so knowledge can be knowledge can be shared among different applications. That particular term is called as interoperability. Whereas the traditional knowledge representation, it focuses on how the knowledge is internally represented and reasoned within a specific system. The knowledge which we represent using this technology cannot be shared. That is specific to a particular system. Maybe the educational system, maybe the healthcare system, maybe the IRCTC system. So that all the systems are unique and they are independent. The knowledge about that particular domain is also independent. So that is why that type of knowledge is considered as the traditional knowledge representation. Now come to the structure. Structure is also one of the, based upon the structure, what is the structure of the ontological engineering? So it uses the classes, properties, and the means the relations, and the axioms means the rules and relationships in a well-defined hierarchical format, and especially to represent the class, subclass, their relation, properties, axioms, everything we can represent using different types of languages. Like one of the languages OWL, another one is RDF. OWL is a web ontology language, and RDF is resource definition framework. Whereas the traditional representation technique, it uses the constructs like production rules, frames, semantic nets, or propositional or first order logic, as I have discussed just now. Now, based upon the flexibility and reuse, it is high reuse potential, supports modular and scalable knowledge bases, whereas it is system specific. It is specific to a particular domain and particular system, not shareable, harder to reuse or integrate with external system. So that is the difference between your ontological engineering and the traditional knowledge representation technique. So this is all about a few questions only I have discussed because of the time constraint. Again, I'm telling you, I hope you might have understood. And if you want to know all the answers, then you can watch all the previous videos which I have prepared module wise. So, and for the preparation of this video, I have followed this Soros Kosik book for artificial intelligence. For your reference, I kept the picture of the book also, which is available on the Amazon website. That link also I have given on the screen. So next class I will discuss a few questions based upon the module knowledge representation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.